So next one is improved series voltage regulator. So here first I will discuss how to get your output expression, and then I will be telling the operation of this circuit. So here if I am writing the KVL on this loop, so I should write first the KVL on this loop. So if I am writing the KVL on this loop, so this is minus 2 plus VBE2. So I can write it as plus VBE2 minus 2 plus. So plus V is Z. Now this is V2 voltage across R2. I can write it as plus 2 minus. So minus V2 should be equal to 0. Or this I can write as V2 should be equal to VBE2 plus VZ. Now, see what is your output voltage over here. Output voltage means, okay, I'll first write what is V2 here. So V2 means voltage across R2. So I can write here V2 is equal to VR2. What is VR2? The current through I2 multiplied by current through R2 multiplied by R2. What is the current through R2? It is the voltage. This voltage is VO. So voltage V out divided by R1 plus R2. That is the current. So VO divided by R1 plus R2 multiplied by your R2. This is voltage division rule. Now if I am writing in from here, if I am writing VO, what is my VO? VO should be equal to, just cross multiply. So I can get it as V2 into R1 plus R2 divided by R2. Now you must be knowing, now here you derived what is V2. Just substitute the value of V2 from here to here. So you be getting as V out should be equal to V2 is VBE2 plus VZ into R1 plus R2 divided by R2. So this is the expression for V out for an improved series voltage regulator. Now here, now I'll go to the operation of this circuit. See here R1 and R2. This one R1 and R2. This is the sampling circuit here. This one is the sampling circuit. Now this VZ. VZ will be acting as provides the reference voltage. So VZ will be providing the reference voltage. Now Q1 is the series control element. Compared to your previous block diagram, Q1 is a series control element. Q2 will be controlling the base current of Q1. Q2 will be controlling the base current of Q1. Now we'll go to the operation. So just discuss now the operation of improved series voltage regulator. Suppose if your output voltage, so now I'll be discussing the operation. If the output voltage is tried to increase, when output voltage increases, you know the expression output voltage should be equal to this expression, but when VO increases means your VR2, the voltage across R2 also will increase. So VO increases, that means voltage across R2, that means this implies that V2 increases. So what is V2? You know the expression for V2. V2 is equal to VBE2 plus VZ. VZ is a fixed reference. So V2 increases means VB2 will increase. VB2 means it is the base to emitter voltage of transistor Q2. So this increases means that this transistor will conduct more. If this conduct more implies that the base current of this transistor will decrease, because this conducts means almost all current can go down. So base current will decrease. Base current is decreased means this transistor will conduct less. Transistor Q1 will conduct less. So it will pass less input voltage to the output. Less input voltage only will be passed to the output. So when your output tries to increase, this Q1 will pass less input voltage so that output will be decreased and it will maintain a constant value. I will tell one more time. If VO increases, it means that your V2, because R1, R2, R2 all are fixed. So VO increased means V2 increased. V2 increased means from your expression V2 is VB2 plus V2. V2, no, this is V is Z, okay. This one is, don't confuse, this is the fixed reference voltage that V is Z. V is Z. So that is VZ is reference voltage that is fixed. So V2 increased means only VB2 will increase. VB2 base to emitter voltage of this transistor is increased means this transistor will conduct more. If it conducts more, it will pass almost all base current away from transistor Q1. So this will conduct less. Less means output voltage try to decrease because it will pass less voltage only to the output. So that way it will maintain the constant output voltage. Now next case. Suppose if your VO decreased. VO decreased implies that V2 decreased. So V2 decreased means VB2 decreased. VB2 also decreased. So transistor Q2 conducts less. Q2 will conduct less. So Q1 conducts more. So that implies that Q1 conducts more. When Q1 conducts more means almost all input voltage will pass to the output voltage. It will pass more input voltage, so output will increase. So your output voltage will increase. So VO will increase ultimately. So this is the way it is regulating. Now, so this one is more have good performance compared to the series voltage regulator what we discussed earlier, because it is having a additional circuit. R1, R2 will be providing the sampling circuit, one extra transistor, not only one transistor, two transistor is there. So amplification factor also will be increasing. Now next is a series regulator using operation amplifier. The two series regulator what we discuss now are using transistors. So this one is using an operation amplifier. So this is the circuit diagram. It consists of an operation amplifier. This will be acting as a comparator. You have a VZ, that is a reference voltage it will provide, the Zener diode. Transistor will be the control element over here. So here this op-amp compares the fixed voltage, the Zener voltage, with the feedback voltage sensing from R1 and R2. So the output feedback voltage sensed by R1 and R2, it will compare these two and providing the output. That output will be controlling your transistor Q1. So based on that, this is the control element. It will decide whether the output voltage should get increased or decreased. So I'll explain one more time. This operation amplifier is a comparator. and Zener diode will be providing the reference voltage. R1, R2 will be the sampling circuit, so that this through R1 and R2 output voltage is feeding back to this. Now this is the control element. Transistor Q1 is the control element. So here the if suppose the output voltage tries to increase or decrease, that will be given to this feeding back to here, thus op amp. This will compare against the fixed reference voltage. Now the output of this op amp will decide whether the transistor Q1 to conduct more or less according to your output voltage conditions. So in order to regulate the output voltage, if output voltage is decreases, the transistor will conduct more, so that the output voltage will get increased. If any chance your output voltage was decreased, this will conduct, and output voltage is increased, this will conduct less, so that output voltage is getting decreased, so that it will maintain again the constant output voltage. Now I'll just see how you are getting this expression. I'll show you how you are getting the expression. See here, this voltage is nothing but it is the V is that Zener voltage. And what about this voltage? It at the inverting terminal, the voltage equal to, say this is VR2. So the same VR2 will come here. Okay, so what is VR2? Means by virtual ground concept I can write here VZ also should be equal to VR2. And what is VR2? By voltage division rule, VR2 should be equal to VO divided by R1 plus R2 multiplied by R2. That is VR2. So here I can get the output voltage VO as VO should be equal to cross multiply. It is VZ into R1 plus R2 divided by R2. Or I can write this as VZ into, this is R2 by R2, 1. 1 plus R1 by R2. Both are same. So this is the output expression, the same, that only I wrote here how to get it. So we are getting from this thing. Here the op amp, it places a negligible load on the Zener diode, allowing it to operate at a single fixed point. Hence, a very stable output you will be getting from the Zener diode. So since op amp is here, it will not provide much load to the Zener diode. So it will be operating on a fixed stable point and provides a stable output. And also the Zener diode no longer must absorb the large swings of current. These are the two advantages of using Zener diode here. So, and also here, to bias the transistor here, the output voltage of op amp must exceed the circuit's output voltage Vout by 0.7 volt, because here you see the base to emitter voltage is 0.7. So if I can write here, this is the output voltage of op amp, Vout of op amp. Say I'll write it as op amp. So here I can write V op amp should be equal to, this is 0.7 plus your VO. So in order to keep the transistor on or off, control the transistor, this V op amp voltage should exceed 0.7 voltage by your output. So that is about op amp series regulator. Thank you.